Hello everyone, welcome back to another lesson on measurement. Today we're going to be looking at solving measurement problems. We're going to go through a few examples as well as some strategies on how we can solve measurement questions. Let's have a look at our concept map for today. Cool everyone, so I'm first going to remind you of what a polyhedron is. Then I'm also going to revise the definitions of surface area and volume. We're then going to move on to some examples of measurement, but we're also going to have a look at some examples that combine different shapes. And we're going to see what we do when we have multiple different shapes appearing in a single measurement problem. So guys, let's go on to the first definition. So a polyhedron. We have discussed previously, but just in case this is your first time with us today, a polyhedron is a three-dimensional figure with 4 or more flat surfaces. I'm just going to pause at this point just to make sure you're all with me. A polyhedron is a three-dimensional shape. So essentially it's a shape that I could actually hold. It could be a spherical ball or a box of chocolates. It's not a two-dimensional shape because a two-dimensional shape could be drawn on a flat piece of paper. So if I drew a circle on a flat piece of paper, that's two-dimensional. Whereas a three-dimensional figure would be that spherical ball. So a polyhedron is a three-dimensional shape. Let's go back to the board. Cool. The next thing I just want to revise with you is the surface area of a particular shape. So the total surface area of a polyhedron can be found by adding together the areas of each face of a polyhedron together. So, guys, essentially the surface area has to do with the area that makes up the exterior of the shape. So, for instance, if we're finding the surface area of a cube, I know that the area is made up of 6 external squares. So I would add the areas of those 6 external squares together, and that would be the surface area of the cube. So surface area has got to do with what is on the outside of that three-dimensional shape, and we find the area of that outer part of the shape. Let's go to the next definition. So volume. The volume of a three-dimensional shape refers to the capacity that the shape has. So for instance, if you have a can of cool drink, we know that that cool drink has a capacity. It can hold only a certain amount of cool drink, and that is the volume of that cool drink. Cool. So the volume of a three-dimensional shape is determined by working out the area of the base of the object, and once we have worked out the area of the base, we then multiply it by the perpendicular height. So please make sure that you highlight the fact that it is the perpendicular height when working with volume. So it has to be the height that is at a right angle to the base. Cool, guys? So the next thing that I'm going to discuss with you guys is problems involving combined shapes. So for measurement problems, it is crucial that we consider the words of the question carefully. So guys, it just means that we have to read what the question is asking of us, because it could indicate if I'm subtracting volumes from each other, adding. Just the words of the question give us a lot of direction, but we'll get more into that as we look at examples. Then also, please pay special attention to any indication that any shapes or surface areas or volumes have been removed from the whole. Sorry, this is supposed to say from, not form. So, for instance, if we have got a box and you've removed the top layer of the box, we know that that would be excluded in the surface area. Then lastly, it's important to visualize the problem. So if you're given a situation where you're picturing a house, or if you've been given a situation where you've got possibly triangular prisms in a box, it's important for us to actually visualize the problem, because this will help us solve the questions. Cool, guys, I'm going to go on to the first example. So you are given the following diagram where a large golden circle has been painted on a rectangular field. we're first going to be determining the area of the field that is not golden. So everyone, hopefully at this point, you can see that I have two shapes involved in this question. I have the rectangular field and I have my large gold circle in the middle. My project or my mission is to determine the area of this field that is not golden. So what I'm going to have to do is determine the area of the field in general, and then I'm going to have to subtract the portion that is golden, because by doing that, I'll find out how much of this field is not golden. Let's go back to the board. So we need to figure out this region. So essentially the region of the field that is not gold. We want to know what that area is. The first thing that I'm going to do is look at the area of the field in general. And we know that if it is a rectangle, it's going to be length times breadth. But something that I do want to highlight to everyone, and I hope that everyone is okay with this, we have measurements in centimeters and meters. But when I'm working with a problem where I'm working out the area, I need it to be in the same units. So what I'm going to do is centimeters, I know I can convert to meters by dividing by 100. So 10,500 centimeters is the same thing as 105 meters. So I can use that 105 meters in my calculation. So the area of the field will be 105 times 68. And if I get my calculator, 105 times 68 is going to give me 7,140. Next, I'm going to need the area of the golden circle. And I know that the area of a circle is equal to pi r squared. And luckily, I've been given my radius nicely. It is 15 meters. So the area of the circle will be pi times 15 squared. So I can pop that in my calculator as well. So pi times 15 squared gives me 706,86. And lastly, I need to find the area of this field that is not golden. So I'm going to take the area of the whole field and subtract the golden part. So I'm going to have 7,140 minus 706,86. And that's going to give me an answer of 6,433,14. And the answer will be in meters squared as it is an area. Wonderful, everyone. After the break, we're going to be looking at some more measurement examples. See you soon.